Welcome to the DIY Honda Garage channel. The DTC P0A94-01 indicates a performance problem related to the DC-DC converter in the Honda CR-V 2023 model and later. This specific diagnostic trouble code, DTC, signifies that the powertrain control module, PCM, has detected a malfunction within the DC-DC converter system. The DC-DC converter is responsible for converting DC voltage from the electric vehicle's battery to power other electrical systems. It plays a crucial role in the vehicle's energy management, ensuring that sufficient power is supplied where needed. When the PCM receives failure data from the DC-DC converter, it records this DTC to indicate an abnormality, allowing for effective troubleshooting of the issue. Understanding the significance of this code is critical for the technician, as it can point towards several components, including the DC-DC converter itself, the power supply circuits, or the PCM. Proper diagnosis is necessary to isolate the issue and plan the appropriate remedies. The error indicated by DTC P0A94-01 involves a failure within the DC-DC converter, which is integral to supplying electricity to various vehicle components. The PCM, or Powertrain Control Module, analyzes data from the DC-DC converter and, recognizing a fault, logs this code to alert the technician. The DC-DC converter is typically located within the vehicle's electrical system, often near the battery or inverter area. It functions by converting high-voltage DC from the battery into lower-voltage DC required for auxiliary systems. This failure can disrupt the flow of power that various vehicle circuits depend on, resulting in significant operational issues. When diagnosing, it is crucial to verify the PCM's assessment against the actual operational status of the converter and its associated wiring. Multiple factors can lead to DTC P0A94-01 being triggered. A common cause is shorted wiring within the DC-DC converter circuits, which may prevent proper communication between components. These shorts can occur due to various reasons, including wear and tear, exposure to moisture, or manufacturing defects. Additionally, a problem with the DC-DC converter itself could arise. This could be due to internal component failure or degraded performance. Alternatively, the PCM may not interpret the signals correctly, indicating an issue with its functionality. Each of these potential causes must be carefully evaluated during the diagnostic process to determine the actual fault. Identifying the root cause is essential for effective repair and restoring proper vehicle functionality. Symptoms associated with DTC P0A94-01 can manifest in various ways. The most common indicator is the illumination of the engine warning light on the dashboard, signaling that there is an issue requiring attention. Additionally, because the DC-DC converter is vital for generating power for electrical systems, drivers may notice reduced functionality in auxiliary components, such as the infotainment system or other electronic accessories. In some cases, performance issues may arise, such as hesitations or stalling, as the PCM compensates for the insufficient power supply. If left unaddressed, these symptoms may worsen, leading to more significant faults and potentially hindering vehicle operability. Thus, it is essential to diagnose the DTC promptly to prevent comprehensive electronic system failures. The first step in troubleshooting DTC P0A94-01 involves a simple yet critical action: test driving the vehicle and observing how it performs under real conditions. This procedure allows the technician to confirm the existence of symptoms associated with the DC-DC converter performance issue. Additionally, stopping the engine using the auto idle stop feature, serves as an essential diagnostic tool. This action can create conditions where the fault in the DC-DC converter may become more noticeable. Variability in vehicle behavior during this process offers insights into the operational status of the DC-DC converter and associated components. Evaluating these observations properly aids in narrowing down the troubleshooting pathway effectively. In the second troubleshooting step, it becomes crucial to confirm the results using the HDS, or Honda Diagnostic System. The technician must check the DC-DC converter CST error reading. If the value indicates malfunction, it strongly suggests that the DC-DC converter is the source of the error, necessitating further inspection. On the other hand, if the error shows normal, it indicates that the reported issue may not stem from the converter itself, but potentially from other connected systems or components. Understanding the data from the HDS helps refine the diagnostic approach, guiding the technician toward which components need to be tested next. This step is vital in establishing a systematic troubleshooting protocol. For the third step in troubleshooting DTC P0A94-01, the technician must conduct a thorough inspection of the external circuits connected to the DC-DC converter. This includes checking for shorted wires or any dislodged connections that may hinder proper electrical flow. The integrity of these circuits is essential, as even the smallest break in continuity can cause significant malfunctions. During this inspection, specific attention should be given to the wiring harnesses for signs of wear, corrosion, or breaks. Basic tests, such as continuity and resistance checks, can quickly determine if the circuits are functioning normally or if further action is necessary. A comprehensive evaluation in this step lays the groundwork for ensuring reliable circuit operation before moving forward with checks on the DC-DC converter itself. The fourth step requires an inspection of the DC-DC converter's output circuits, primarily focusing on DC-DC out 1 and DC-DC out 2. The technician should confirm whether any aftermarket parts are connected to these circuits, as they can trigger unexpected behavior and errors in the electric system. Domestic electrical connections must also be scrutinized for signs of damage or improper attachments. The vehicle should be in the on mode while performing these checks. Using the HDS to confirm that the output values are normal according to specifications. If any output errors are detected, it indicates a need for deeper exploration into the DC-DC converter's functionality. This procedure is critical in detecting problems related to faulty output signals. Step 5 involves a comprehensive inspection of the DC-DC converter's internal circuits. Unfortunately, there isn't a direct method to test the internal components themselves. Therefore, technicians rely heavily on diagnostic parameters monitored by the HDS. The HDS should be employed to check for DC-DC converter, syst error, input error 1 and 2, and output error 1 and 2. Each of these parameters provides valuable insights into the operational health of the DC-DC converter and its performance. If all parameters are showing normal, this will imply that the internal circuit may not be the issue. However, if any abnormality is detected, it can suggest serious internal faults, requiring further inspection or replacement measures. In troubleshooting step 6, technicians utilize a known good DC-DC converter to verify the fault. This process is pivotal as it allows for direct comparison against the original unit. By replacing the suspected faulty converter with a functional one, technicians can observe whether the issues persist. If the symptoms or the DTC P0A94-01 reappears, it indicates that other related components might be responsible for the issue. Conversely, if the error disappears, it reflects that the original DC-DC converter is likely faulty and should be replaced. Conducting this step is crucial in confirming diagnosis, facilitating accurate repairs, and ensuring the vehicle performs as intended thereafter. The final step in troubleshooting DTC P0A94-01 involves inspecting the Powertrain Control Module, or PCM. If all previous inspections indicated normal conditions, it becomes evident that the PCM may be the source of the issue. Proper operation of the PCM is crucial for effective communication with other systems and for accurate data processing. Technicians will conduct tests to confirm that the PCM is functioning as expected and assessing any potential faults causing the DTC to trigger. If the PCM does show signs of failure, it must be addressed immediately to prevent other systems from being affected. This thorough examination ensures that any PCM-related issues are corrected, thereby restoring the vehicle's full operational capability. After completing all troubleshooting steps and necessary repairs for DTC P0A94-01, it's vital to conduct a final verification process. This involves retesting the vehicle to check if the DTC P0A94-01 has been cleared from the system after repairs. The technician should use the HDS to ensure no new error codes have emerged and that previous symptoms have been resolved effectively. Additionally, a test drive may help confirm that the DC-DC converter functions optimally and that all related systems operate without issues. Sustaining a proactive approach to resolving these codes not only ensures optimal vehicle performance, but also enhances the overall safety and reliability of the Honda CR-V. To prevent the occurrence of DTC P0A94-01 in the future, implementing routine maintenance practices is crucial. Regular inspections of the DC-DC converter and associated wiring help catch potential issues early before they escalate into serious faults. Maintaining clean and secure electrical connections can significantly avert shorts or disconnections that contribute to DTC triggers. Additionally, periodic checks of the vehicle's electrical system assist in identifying any degradation in performance, allowing for timely interventions. Educating vehicle owners about the importance of electrical care can prolong the lifespan of the DC-DC converter and the overall vehicle functionality. It's all about fostering a maintenance culture that ultimately ensures reliability and performance. In conclusion, DTC P0A94-01 signifies a performance problem within the DC-DC converter of the Honda CR-V 2023 and later models. Understanding the components involved and their functions is essential for effective troubleshooting. A systematic approach in diagnosing the issue leads to accurate identification of faults and their resolutions. Equally important is the implementation of preventive maintenance practices to safeguard against future warnings and enhance vehicle reliability. Ultimately, recognizing the symptoms early and adhering to a structured diagnostic protocol can not only save time during repairs, but also ensure that the vehicle maintains its operational excellence over time. Addressing issues proactively fosters an environment where vehicles are performing efficiently, ensuring satisfaction and safety for drivers and passengers alike. Please like and subscribe to the channel. See you next time.